speaker's topic, which is smart energy efficiency application. Haris KR. He is the Associate Director of Consistent Engineering Consultants. I welcome him to the panel, and the floor is yours.
Good afternoon, Mr. Abbas, and good afternoon, all the attendees. It's my pleasure to present a small session with smart energy efficiency application. I'm Haris from Consistent Engineering Consultants, Dubai.
You can.
Yes, sorry.
Yep, no one. Okay, good. There we go.
Okay, smart energy efficiency application. The building where we live, work, and entertain absorbs more than 42% of the world's energy consumption due to heating, cooling, and lighting systems. So the majority of the energy is being consumed for these systems. And in considering the current development scenarios, over the next 25 years, the worldwide energy demand is expected to grow over 40%. So considering this, and it is an urgent need for smart energy efficiency applications. Smart energy in buildings mainly it consists of the mechanical, electrical equipments which connected with Internet of Things. The main objective of the smart energy technology is to reduce the energy cost and environment impact in building life cycle. In buildings, various kinds of energies like cooling, heating, hot water, lighting, electricity, gas is used on daily basis to provide safety and comfort to the occupants. So by doing the Internet of Things is nothing but all kinds of sensors, meters, counters, all these things is considered as Internet of Things, which connects from device to the cloud, and I will show in the next slide more detail. So in the Internet of Things, what we have under the smart energy, smart metering, smart lighting, smart grid, net metering, smart building energy management systems, daylighting, smart HVAC systems. These are the major technologies being used to achieve a smart building architecture. Nowadays, we all know that the buildings are LEED certified, and it is going towards a sustainability applications. Even though a LEED certified gold building with centralized and static building controls, the actual running of the green building may not be energy efficient, even though they are green by design. What I mean is, you have a static controls, but if you don't have the regular updates on energy consumption and energy usage and adjustments to the systems, the green building as a standalone building, yes, it will have the certification qualifications, but on an energy saving methodology, unless and until if you don't have a proper control, centralized control, you will not get the end results of energy saving. So that's where we come up with the energy proportional computing and IoT framework with smart location-based automated and network energy control, which uses smart platform. You can see in the slide, there are things which can be connected, like HVAC, energy, smart lighting, light, noise sensors, smoke sensors. All these things go through a smart management platform, and it is cloud-based building management application from there user interface is connected. So in this IoT network, with a smart location-based automated and network energy control, the cloud computing technologies to enable multi-scale energy proportionality. It is multi-scaling energy proportionality. The solution has not only led to the significant economic benefits in terms of energy saving, it improves home and office network intelligence, but also brought in a huge social implication in terms of global sustainability. The next one is basically the optimization on energy. In order to get an optimization, we need to have a clear identity. Clearly we need to identify the baseline and the behavior of the system. So mainly we have three systems, the major loads in the building, that's HVAC, lighting, and plug loads. So we need to optimize this energy by use of intelligent applications. Optimizing the energy, usage to maximize the benefits of the people as well as the environment. It consists of three concurrent strategies: saving energy, managing demand response, and using renewable energy. The equipment performance, again, we all know that the standard building automation, okay, it's only possible to monitor the system healthy on, off, and it's not giving a continuous update or the running status remotely. So in order to get that, we need to have the solution where it will give the updates on regular basis, so that in cases where in an electrical distribution system where your motor is running on a high load, and if it is not being monitored properly, or if it is not being investigated in real time, there will be a breakdown. So in order to get out of these situations, there is actually the system is available where you can monitor the electrical parameters of the running system continuously within a span of 30 seconds to one. Each 30 seconds, the signal will be transmitted with the current monitoring status. So there you can monitor, and then you can notify the energy managers or building managers the course of action to fix the problems. So in electrical distribution, as you all know, that harmonic distortion caused by non-linear loads is a common issue that can damage the electrical components. In the same way, transient swells and undervoltage events can have a harmful effect on the equipment as well. So the power quality management features coupled with the general device information can help to identify the problem early, so that the damage and downtime can be minimized, if not eliminated entirely. The system, one of the other main points is that the scalability. The system, whichever is applicable on energy efficiency application, it should be scalable. It should be possible to design and with the different architecture sizes with adoption of one single communication module, or it shall be possible to integrate more communication modules to supervise the electrical installation according to the number of devices interconnected and functionalities required. And scalable is what the technology nowadays available with most of the manufacturers and most of the system providers, so that if you have an architectural available, okay, you can add, modify with a plug-and-play arrangement. Okay, you don't need to rewire, or you don't need to reinstall a complete system. It's always scalable, and the system is good for any future expansion without any downtime. Okay, and it is all these systems is connected with the cloud supervision devices as well as the electrical components. From the main panel to the sub distribution boards and the final distribution boards, all the components are connected and monitored. And the standards on the electrical side, we have the standards to follow. Mainly the IEC 60947, that's a low voltage switch gear and all the control gears. IEC 611313, that's for the programmable controllers. And IEC 608705104, that's a telecontrol equipment and systems. And IEC 6110004, the electromagnetic compatibility testing and measurement packages. The building energy management system, it's a cloud-based building energy management site. It's a cloud-based building energy management system. It can access to the meters, sensors, all the information in the building through the internet. The information is collected from the building automation system through a secured IP connection, and the end user access their information by logging into a dedicated website using their unique username and password, so that all the information is available in handy, and any variance, it could be reported and it could be attended without any delay or without any breakdown. Building energy management open source software solution is engineered to improve sensing and control of equipment in the buildings. And open source software solution is such that you can have any third parties softwares, any third parties integration is possible without any additional interfaces. Open architecture software solution this is a best option to improve your sensing and control of all IoT enabled equipment in any kind of buildings. The other one we need to look at it, the intelligent efficiency. The system connected devices, they respond to changing conditions of the external environment in order to maximize the energy savings. Okay, the operational conditions an office building, let's look at an office building, whether it is fully occupied or semi-occupied, or it is the vacation season. So depends upon the system and as well as the environmental condition, external environmental condition, summer, winter. So all these things can be monitored and adjusted, the energy efficiency, so that the utility can be controlled in such a way that the end user is paying only the bill which is being used at depends upon the applications. There are instances you will see that the energy is being wasted in such a way that the light is on full time and okay. So I have 3 more minutes to go. Demand flexibility. Changes in the electricity usage by end user. That's again, there are demand flexibility is also applicable when you look through the building energy management system. So depends upon the customers from their normal consumption pattern to changing market conditions of the power, the supply conditions. So that's also need to be looked at. And the supervision system, as I said, it's a cloud-based system to have the data logging interval at every 30 seconds. Every 30 seconds. That is to ensure that fast reaction in case of warning or alerts and continuous measurements for reliable efficiency analysis. This is good for any operation of any plant or any motors or any running loads, where on a normal scenario, no one will notice if there is any fault is coming up. So by looking at it 30 seconds intervals at a data logging, it will give a real warning, and that can, supervision system, that architect, the supervision you can control and all the damages, whatever you can cause the delay, you can avoid. The supervision system architecture is also a communication model with integrated software that behaves as a concentrated gateway, allowing management of parts of electrical system located in different areas directly based on the application. Okay, so this is a small presentation on smart energy. I hope we all enjoyed, and thanks for giving me this opportunity. Thanks to the organizer and thanks to Mr. Abbas.
Thank you very much, Haris. Very insightful, very knowledge, a lot of knowledge there. I know more the technical people also enjoyed that because you got into a little deep in the technology, which was great. We have listeners and we have audiences right now from around the world. So thank you very much for your